Okay, so now we're going to try to be more precise. I'm going to write the numbers over here for the first number, second number, third number, fourth number, fifth number, sixth number. Okay? For how many rolls it should take.
Right.
I scrambled up the dice a little bit. All right, so who wants to roll the first dice? Pick it up, but don't roll it. All right, how many rolls should it take us to get the first number?
1.
Okay. Let's see if we get it. Yes. All right. Over there.
Right.
So why would it only take 1 roll to get the first?
Because you don't have any repeats you can get.
You don't have any repeats. All the slots are open.
Yeah.
Okay. So now a trickier question. How many rolls should it take to get the second number?
Well, you have a 5/6 chance of getting a new number.
Okay. So you have a 5/6 chance of getting a new number and a 1/6 chance
of repeating.
Of having to repeat.
So if you round this up, you get 1.
Well, that's true. Why are you thinking that would help?
Well, it's pretty close to 1.
It's pretty close to 1.
But
So
you could get a repeat.
yeah, but you could get a repeat. So is the expected number of rolls to get our second number going to be more than 1 or less than 1?
It should be more than 1.
Okay.
I guess. Because less than 1 would be weird.
Yeah. How about equal to 1? Should the expected number of rolls be equal to 1?
Well, no, because it's possible that you can't get a repeat.
Okay. So what do we think the expected number of rolls it's going to take to get the second number is going to be?
2 maybe?
Do you think it's going to take 2? Does that seem right? Do you think it should always, on average, if you did this 100 times, do you think it would take 2 rolls?
No, I think. Well, if you did this a bunch of times, it's going to be 1 most of that time. Like if you did it, let's say 60 times.
Yeah.
It'll be 1/50 of those times.
Ah, okay.
It'll be 2 less. It'll be way less that it's 2. And then like 3 rolls.
Well, that's an interesting question. So it'd be 1. So you said 60 times. This is a nice way to think about it. You picked 60, so I'll do 60. So 60 rolls. 50 of them on average should take 1. 5 out of 6.
Yeah.
Right? Approximately how many should take 2 rolls?
Well,
10.
Well, 5 out of 6 of your 10.
Okay, so 5 out of 6 of the 10. So now we have 10 times where we have to roll again. And what's the probability that we get it when we roll?
Oh, well, 5/6.
That's right. So we have 10 of them left, right?
Yeah.
So we have the probability of 5/6 times 10
That's
is
going to be 50 over 6.
50 over 6. We don't need to simplify it. 50 over 6, but is that all the cases left?
Well, no, because
It's not.
we haven't used all our numbers. You could have 3.
50 over 6 is a little bit more than 8, right?
Yeah.
It's 8 would be 48 over 6.
So it's
So
8 1/3.
Right, so it's
you-
8 1/3.
So you have a little bit left.
8 1/3.
So
So-
you have
Now we have 5/3 left, right?
Mm-hmm.
5.
And then 5/6 of those 5/3.
Right, so 5/3 times 5/6.
That's 25 over 18.
25 over 18 times is going to take 3. So what's going on here?
Well, it's
getting
sort of an infinite. It's like an infinite series. You're just getting smaller and
smaller.
smaller probabilities.
Yeah, it's an infinite series. So we have 5/6 is the first term. The second term is 1/6 times 5/6. What's the third term? This is we get it on our first try. This is we get it on our second try.
And then our third try would be 1/6 times 1/6 times 5/6.
Right, so 1/6. In other words, we miss.
And then we miss again.
All right, can you tell me what the fourth term is going to be?
1/6 times 1/6 times 1/6 times 5/6.
Right, so we have this infinite series that's a little tricky. It's 5/6 out in the front, because that was in all the terms. And then it's 1 plus 1/6 plus 1/36 plus 1/216. Okay?
Yeah.
All right, so we need to talk about this infinite series.